Yeah. I'm just trying to make sure it's true charts. Ah, no. Stop it, computer. Okay. Okay, I think we're gonna go ahead and get started. And surprisingly, we already have a question of how's your day been going? It's going pretty good. Thanks for asking. I'm a little sore, but I'm gonna try to make through this presentation. So today we're gonna talk about a topic area typically when it comes to pen testing that a lot of people tend to struggle with or kind of get lost in, which we typically call privilege escalation or privesking if you want to get fancy with it. If you haven't signed in, please do sign in. We need these numbers to prove that we are an organization and that we do things so they can keep buying us pizza. Before we get started, we're going to have some announcements. October 21st, we're going to be hosting the Cambrian Cyber Group on that Monday. We'll have Alchemy right after that on October 28th. We have Fire Talks on October 30th. If you don't know what Fire Talk is, it's a 5 to 10 minute presentation given by y'all to us and everybody else CSG, talking about something you've done in security, something you developed, or something that you just find interesting and you want to share your knowledge with people. We don't have that many signups yet. I'm very disappointed. Come on, people. I'm tired of talking. Let me listen for once, damn it. All right. November 4th, we're going to have TI. We're going to have them here, going to be talking with you all. And officer applications. I'm an officer. I'm pretty cool. You want to be cool like me? Apply to be an officer. Boom. All right. Now we got that through. So, we're going to start off with what is privileged escalation. Privileged escalation is typically defined as the act of explaining a bug, design flaw, a configuration, oversight on an operating system or software application to gain elevated access to resources that are normally protected from the application or specific user. This is typically trying to exploit maybe an actual vulnerability in some code, maybe somebody set something up weird, or they gave wrong permissions or over permissions to something that you typically try to exploit to get more permissions on the system, typically escalating through different users who have more permissions, either from a regular user trying to get up to the root or get to actual system access. Why is privileging so hard? A lot of people have a lot of difficulty with privesking systems. It's kind of a hard topic to actually get good at because you're confined to the actual operating system. When you're actually starting off, when you're trying to pen test a machine, you got the whole network to work with. You're a little bit more free to do what you want. You can actually load whatever tools you want, since you can actually load what binaries and stuff like that. When you get on the system, you're confined to what's actually on the system installed already and what's running on there. So if you want to run an exploit that's written in Python, but the machine doesn't have Python written on it, well, you're kind of screwed a little bit there. You might have to find a backwards way to getting a Python binary on the machine, or you might have to find a way to compile that script into something executable. There's also a lot of moving parts in operating systems. The operating systems are massive and they are confusing and they do a lot of different things. So trying to move around the system and try to get it to do something it's not meant to do can be kind of difficult, and sometimes if you don't know exactly what you're looking for. Also, people or sysadmins set up stuff weird. Everybody sets systems up differently. Everybody has their own way of standing things up. Some things are normal and some things are just downright bizarre. Like, why would you do that? And when you get onto the system, it's kind of you have to adapt to what you see. And when you're looking at things, you're like, why would someone ever do this? This is freaking stupid. This is just beyond annoying. Why would this make your life easier? You kind of have to adapt to what people do, because people are going to do things wrong. We're human. We make mistakes. But we have to kind of take advantage of those mistakes that people make. It's also a needle in the haystack. When you get onto a system, a lot of time there might not be like 70 different ways to get privesking. There might be one or two, and you kind of have to dig down and figure out where that is. That can sometimes kind of be hard, because when you try to enumerate a machine and try to figure out more about it, it's going to dump a lot of information at you. And if you don't know exactly what you're looking at, you're going to get kind of lost of, okay, how do I exploit that little tiny thing on the machine? And also, oh my freaking God, so many version numbers. If kernels update fast, because if there's something wrong with it, you need to patch it fast because it's very important to. So they have very many different types of versions. If you try to find an exploit, Well, you're going to find maybe 17 exploits that work with 15 different version numbers, and trying to figure out specifically which one's vulnerable to is kind of hard. And also, a lot of companies, they name their version numbers weird. Maybe though 6.2 is lower than 6.11, but in some areas 6.11 is lower than 6.2 because 6.2 is technically 6.20 in a sense. It confuses me, and you're looking through documentation, you're like, I hate this company, why would you do this? You're making my life harder. That's why when you're trying to find ways to do things, you're trying to find exploits for certain services, trying to pin up the exact information to figure out what would actually work can kind of be kind of hard. So what can actually help me escalate on a machine? Well, there's a lot of different things that can actually help escalate on a machine. There's kernel exploits, actually exploiting the operating system itself to do something it's not supposed to. These ones are kind of hard. People do find them, and they can be of use to us. Sometimes they may not work, sometimes they do, depending on what type of system, and it might be on the actual specific version of the kernel. There's also misconfigured services. Some people like to run services as root or something like that. That's a really bad idea, because if I can get command execution through that service, I am now root on the system. So people set up things in a bad way, and they kind of screw themselves. Also, improper file permissions. Maybe I get into a file that I'm not supposed to see, and I see some code that I know how to actually exploit and maybe prevent us on the system that way. Poorly configured cron jobs. If you know what a cron job is on a Linux system, that's basically a system that's a script or a service is supposed to run at a predefined time every so often. So you get set up to run every 30 minutes, every hour, every fifth or third Monday of October, if you're really that specific or something like that. Sometimes you can take advantage of them running that script so often, you can maybe change the way that the file system is looked at for the script, and it can maybe do something it's not supposed to. Literal passwords lying around. This actually happens. People leave SSH keys, as in the old SSH keys that maybe they thought they revoked but didn't actually revoke, and they still work. Some people leave encrypted passwords lying around, but you know, if I have enough time, I could probably break that password if it's weak enough and stuff like that. Also, improper usage of sudoers. If you don't know what that is, on Linux, there's this file called sudoers. If you've ever done a Linux system, you know the sudo command is to run a command at a higher level of privilege. You can define certain commands for lower users that they can run this command without a password from root and stuff like that, or actual password from that user, and that could lead to some dirty stuff if you know what they're actually trying to run. So how do you actually find out these exploits? Well, there's really only one way to do it, just more good old enumeration. So you did all your enumeration, you found your exploit, you got onto the machine. Well, guess what? You gotta do it all freaking over again, because that's the way it works. You're not gonna see any of this stuff from the outside enumeration. So now you're on the inside, now you gotta enumerate the machine more. It's gonna involve poking and prodding pretty much everything on the system to see what kind of ticks. If you do something, what is the machine, how does it respond? Maybe what is this on this machine? This looks weird. Maybe the user made this. Maybe I can take advantage of it. Luckily, we do have good scripts that people have made outside that actually help us search the machines in a lot faster pace instead of actually going from directory to directory and kind of just looking at what's going on. So I'm going to specifically talk about Windows and Linux privilege escalation in this. I'm not going to be talking about like OpenBSD or anything like that, because you're rarely ever going to run into machines like that. But Windows and Linux are probably the biggest ones you're going to run into. So Windows privilege escalation. What do I need to do if I want to privilege on a Windows machine? This one is, I would say, tough. Windows is hard to privilege on, just by the nature of how Windows is designed. So typically when you get onto a Windows machine, you kind of want to analyze what my user is right now and what capabilities it has. So you want to look at what type of groups it's in, what actually has permissions to go through, and what kind of commands is it allowed to execute and stuff like that. A lot of times on Windows machine, a really good thing to check is probably the services running on the machine. You might have a web server or something like that running on the machine. Maybe you have access to edit that service or something like that, so you can maybe point the binary from that service to maybe the binary that you created yourself and try to get a reverse shell like that. There's different ways you can do it. That's typically one of the more common ones if they set it up sometimes. Also, a lot of times machines, they might host something local host only. And what I mean by that is you won't be able to actually reach that service from outside the machine. You would only be able to reach it while you're on the machine. So it's hosting on its host address on 127.0.0.1. So you might have to find that service on the machine when you're on it, maybe forward that port to your other machine so you can your actual attacker machine to actually reach that service from the outside. Windows has kernel exploits, but don't count on them on working all the time. Anytime I've try to do a kernel exploit on Windows, it's kind of hit or miss. There's the famous ones that a lot of people have heard of and stuff like that, but it's hard to figure out if they're going to work or not. You can check the patch level of a Windows machine. It'll literally list every single patch that it's done, and that's kind of hard to look through because it's really, you have to look up each single one. It's like KRB number. So doing that is kind of hard. There are scripts though that will look at the patch level for you and suggest kernel exploits. That's sometimes helpful, but then again, it's still hit and miss with those type of things. Privilege misconfigurations are probably the most common way to escalate on a Windows machine, because just the way that like Active Directory and user groups are on Windows, they're hard to set up and they're really easy to screw up. One of the most recent ones that are permission based is called Juicy Potato or Rotten Potato. There's another potato one that I don't remember the name of, but that's a good example of a misconfiguration exploit. You might need to use some PowerShell magic. PowerShell has got a lot of good commands that help you try to enumerate and try to get more information out of the machine. And it can do stuff as running as a different user. If you have that user's credentials, you can actually extract passwords through the secure strings and stuff like that. Windows is inherently hard. You kind of just have to delve into it and just see what works. It's probably not the best thing to start off in, but when you're on those types of machines, just try to grab as much information as you can, maybe reference a guide, and maybe that can help you figure out where you might want to go next. Some useful tools. So for enumeration, if we want to actually find out a lot of information about this machine, a good one is called JAWS, which stands for Just Another Windows Script. It will basically enumerate as much information about the machine as possible and try to print it out on the screen so you can basically look at it and say, all right, I have access to these files, I have these permissions, there's the patch level on this right now. Okay, maybe I can do something like this. It helps cut down the time trying to go through directories and such like that. There's another one called Sherlock. It does the same thing as JAWS. PowerSploit, also another PowerShell script that does the same thing. Bloodhound, if you were here last week, I showed Bloodhound trying to exploit Active Directory architecture and stuff like that to Privesc. There's a bunch of tools that I find really good when actually interacting with Windows machine. There's one called Mpacket. This is a bunch of Python scripts that are really good for interacting with a lot of types of Windows protocols. So that could be SMB protocols, LDAP protocols, and stuff like that. So if you're ever interacting with a very specific Windows protocol, Mpacket probably has a good script to help you with that. Nishang is a quick and easy reverse shells for PowerShell. If you don't know what a reverse shell is, basically, if you think about SSHing into a machine, you're connecting from your machine to that machine. A reverse shell is, I'm waiting here, I'm making that machine connect back to me. So it's how you get access to a machine, because you're not going to be able to let that machine let you in. You want it to come to you, in a sense. Covenant, if you're really fancy and you like command and control servers and stuff like that, so you can have a command system on your attacking machine, and you can send out, what do they call them? They call them grunts based on Halo and stuff like that. That's where it comes from. And you can put these clients on the machine, and you can send them tasks while they're on the machine to actually do some enumeration for you. It's an easier way if you're trying to break into a bunch of machines at once to kind of organize which machine you're interacting with and which clients are on which machine and stuff like that. Mimikatz, that is a kind of a lower level tool. It's really good if you're trying to extract encrypted data from the machine. It interacts with their passwords, so you can try to pull out encrypted passwords, encrypted tickets, and stuff like that. It can help sometimes, but finding the area where they'd be useful can be kind of tough. Windows sysinternal. So Windows makes a bunch of tools that actually help us. So there's a bunch of tools that you can download, like Access Check, there's Procmon and stuff like that, that you can download on the machine that are actually Windows made that actually find out more information for us. There's a bunch of them. I can't name all of them off the top of my head. If you just Google Windows sysinternals, you'll probably find a bunch of different executables that you can use. A good resource is also Payload All the Things. It's a GitHub repository that has a bunch of guides on just different payloads, privesking Windows and Linux machines, common techniques, what you should be looking for, and stuff like that. So if you get stuck, I highly recommend going to that GitHub repository, reading what they have. They might have something that, hey, maybe I haven't tried yet, or that looks familiar, maybe I can try to do something with that. How often do I trim my beard? 3 to 4 weeks, I guess. I don't know. I'm getting lazy. It's senioritis. Lol. Yeah. All right. So Linux privesking. Linux is much easier, at least in my opinion, because it's a little bit more free form. They're not as restrictive as Windows is when you come to doing things. And I feel there's a lot more things that you can actually exploit on a Linux machine compared to a Windows machine. So same thing with Linux. You're going to want to try to enumerate as much stuff as possible, everything you can touch. You want to know what I can have access to read to. You want to know what I have access to write to, because you might have a situation where you need to write something specifically to a folder to maybe hijack a path or something like that. Kernel exploits are pretty common here. Linux has many different versions of their kernel, and a lot of them have had pretty bad exploits. Find the right one is tough, though, since there are so many versions of Linux. You have to find out the specific one you're actually vulnerable to. A lot of the time, you probably maybe have heard something called a dirty cow. That's a pretty common exploit. It's a dirty copy on write exploit. I'm not going to get into details of how that actually works and stuff like that. There's also another one called Memo Dipper. That's a pretty common one that came out. Abusing sudo and SUID binaries are really common in Linux. So abusing the sudo command, trying to use sudo so you don't have to give it a password and try to run something and then exploit it that way. There's also binaries which are called set user ID binaries. What that means is when you set the user ID bit on a file, that means every time you run that file on the system, it's always going to run that binary as the user who owns the file. So if the root user owns that file and you run it as a different user, it's going to run as root. So you could try to give it a bad input to try to maybe run a different command, and it would run as root, and that's how you would actually escalate your privilege on that system. You want to check what services are running on the system and who is running them. You might have maybe some type of services that are running as root or a different user. Maybe they did something wrong, and you can actually escalate or exploit that service to try to escalate up to either root or a higher user, which also comes with configuration files. Sometimes configuration files have passwords in them. Maybe you can actually come out of the machine, log into a service from the outside using that password you found in a configuration file, maybe exploit more about that service to actually get on the machine. Cron jobs can lead to escalation if you can figure out their timing and functionality. So if you see that there's a cron job that's running on the machine, maybe you want to check out the script that's running. Maybe it's something you can exploit, and if you can figure out the timing of when it's going to run or something like that, you can actually take advantage of it. Looking at bash history or log files can sometimes be good. A lot of times they get scrubbed, but maybe sometimes they try to type in a password and maybe that's still in their bash history, or maybe they move some files around, which maybe one of the files you noticed was a private key for SSHing, and they started moving it around. Maybe you could try to figure out where they put it and such like that. Do you answer every question we ask? I'm going to damn try to. Hee hee. Beard good, privest hard. I agree. Did you ever participate in Cyber Patriot in high school? I don't know what that is, to be honest. I was in Podunk Prosper when it was little, so we didn't have that. So useful tools in Linux, there's a ton of enumeration scripts for Linux. The biggest one is probably linenum. It'll run through the whole system and try to find as much information and print it out in a very nice organized format for you to be able to see. I like Linux Smart Enumeration because it color codes everything, and I like pretty colors, so that's just me. Linux Priv Checker and Unix Priv X Checker, kind of the same thing. Some of these actually do suggest possible exploits to you if they can figure it out. So those can be kind of useful if you don't have any direction of where you're going. There's a program called PSPy. Is basically a Python script that if you run on the machine, it will log every single command that's run on the machine when it's running. So maybe you have a situation that when you SSH into a machine, it runs a bunch of commands. Maybe I want to know what type of commands are running. Maybe I can hijack those commands when someone logs in and try to escalate that way. And PSPy will allow us to do that really easily. And I'll show that in the demo how I actually use that. Some useful resources is GTFO bins. So I'm pretty sure you know what that means. It means get the fuck out bins. It's more for use if when you get into a machine, there's a area sometimes you can get into called a restricted bash or a restricted shell. It's basically the same thing as a shell, but you're restricted more heavily on your what actual commands you can use. And this has a curated list of almost every single Linux binary that has a way of breaking out of a restricted shell. It's got like 400, 500 different binaries that can break out of a shell, from using Vim or tar to break out of a shell. It's pretty crazy, actually. Like I said, Dirty Cow and Memo Dipper exploit are kind of the most common kernel exploits that you kind of hit. They're more for older machines nowadays. A lot of the newer machines you probably won't be able to do those on, but if you counter like a Linux, I don't remember the version number. I think like Linux Phoenix or something like that, it would probably be exploitable from Dirty Cow. And again, Payload All Things has a Linux section on privesking, so if you ever get lost on what to look for or what to try, that's a good resource to go to. Any more questions? Nope. All right, so you enumerate your system and you're saying, I think my kernel's vulnerable. It seems like a low version. It's kind of old. I think I might try to find an exploit on it. Well, Exploit Database is a good friend of yours. So Exploit Database is run by the Rapid7 guys, the guys who make Nexpose, if you know what that is. They basically curate a whole database of every single exploit and proof of concept of the exploit that they can have. And when you're actually looking for these exploits, you do have to be careful with the version numbers, because if it's one version number off, it possibly won't work. Sometimes a lot of the scripts will name them as, version 2.1 and less. Sometimes it might not work on everything less than that. They just do that just to kind of blanket everything. And also, a lot of the proof of concepts on the website won't work on the machine just as is. You won't be able to just copy and paste the exploit on there and expect it to work. You might have to modify the script a little bit. So if it's like a Python script, maybe it's assuming directories are different than the machine you're on. So you might have to edit where the directors are looking for the exploit for it to actually work on the machine you're trying to get into. Also, not all the scripts on there are verified. Be very careful of what you write or what you run from there. If you're going to run an exploit, understand what the exploit is doing. If you're not doing that, you're going to get into big trouble, because sometimes some people put up a proof of concept and that is actually an exploit trying to exploit your machine. So be careful. Understand what you're trying to run. Don't just run things blindly. Don't be a script kiddie, in a sense. What if I don't have the binary to run the exploit? So what if I have a Python script, but the machine doesn't have Python on it? Well, you have a couple of ways of doing this. You could try in the case of Python, you could try to get a Python binary to the machine. That can sometimes be hard if the machine watches traffic or anything like that. So if you're trying to download a big binary, it might be like, whoa, buddy, what you trying to do here, or something like that. You could try to find a way to make it a standalone executable. Like Python has a package called Python installer or something like that changes a Python script into a C executable. That sometimes work. You kind of have to play around to see what you're able to actually do on the machine. What is your favorite top 3 superheroes, and why is it John Cena 3 times over? I mean, he's America's sweetheart. What can I say? What about Mac OS? Mac OS is a Unix system. It's almost identical to Linux. It's pretty damn close. So if you're prevesting a Linux machine, you're probably going to be doing the same thing on a Mac machine. What's up?
There's actually like a backdoor you can, it's like a built-in backdoor in the system that you can actually go in, punch in some commands, and elevate your own account privilege or whatever.
There's been some things that can escalate on Mac. I know a while ago, if you disable the root user, it was able to re-enable it just by typing in the name again. It would just boot it back up, and you can log into it automatically without doing anything else. So they have their own vulnerability specific for Mac OS, but a lot of the time they don't, because the way they've written their kernel is pretty airtight. Their virus protection is kind of ass though, but to be honest, but yeah.
Mac OS used to be based on Unix, and sometime a while ago they forked off and they went to do their own thing. Maybe no intended there. So it's technically not Unix anymore, but yeah, like there's a lot of similarities in the kernel, and they're also running. Like if you open up a terminal, you have GNU tools, so it's really easy to think that you have like a Linux machine because all the commands are basically the same because they copy paste things.
Yeah, so enumerating a Linux machine is going to be very similar to a Mac machine. How they actually exploit it might be different, but that just depends.
The new OS update they did for Mac OS Catalina has been like the biggest clusterfuck I've ever seen. Stay tuned. There's probably like all sorts of amazing.
And they have some pretty bad exploits sometimes, or vulnerabilities, I would say.
And the way that Apple handles like security is kind of stupid. Like
Their virus protection is terrible, by the way.
their virus
It's
protection
just static signatures. Change one word in that virus, and it gets past it. It's pretty dumb.
Their way of solving the problem of a lot of their old school 32-bit programs being vulnerable was to remove the 32-bit interpreter in the latest version of OS. So
I mean,
yeah, they don't actually try to like they're this is me kind of going on a rant, but their way of solving the problem is by just narrowing the scope of things that they're allowed to do.
I
And
mean,
it's like that's just
it's not vulnerable if you can't freaking run it. Easy.
boom,
Duh. Why didn't we think about this before? Just turn off all computers. Nothing's vulnerable. Done. Easy. All right. But sometimes you get into a situation where I'm like, I got thrown into an R-bash. What do I do? All right, first, calm down. You can get out. I promise. A lot of time you can. Second of all, look at what you can do in the R-bash. Go to GTFO bins. You could probably find something to get out. Most of the time that will work, like probably 95% of the time, since there's so many things you can actually do to get out. So it's just some general tips when you're coming to actually prevesting machines. Document everything that you see. It may seem minor in the long run where you're like, why do I care what the time is on the machine or how off it is from the actual normal time? It may come into use later on. There are exploits that do base it off the time of the machine and how off it is from the actual like time server and stuff like that. So if it doesn't seem important, document it anyway. You might use it. If you don't, it's not that bad that you put it down. Read documentation, because sometimes they might using some kind of specific framework. You might have to figure out and learn that framework right on the spot to figure out how to exploit it. So if they have MongoDB on there and you don't know anything about Mongo, well, guess what? You're about to learn a lot about Mongo to be able to break it. So, and they also do version numbers differently. So if you're trying to figure out if it's below a version number, you might have to read up on the change log to see how they actually do their numbering and stuff like that. Also, keep calm. It's frustrating. Sometimes I want to punch my computer too. It's all right. You'll get through it. Their OS is very picky on purpose. They're trying to be secure, but if you go with it, very easy-headed, you'll break it eventually. I promise. Also, just try to understand what you're exploiting. It's good to actually be able to exploit the machine, but if you can't explain exactly what happened, that might be kind of rough if you're trying to actually gain something from it, because you just say, I ran the script and it worked, okay, but do you even know what actually broke about it or what the actual script did? If you actually know these things, it helps you in a job if you can actually explain what you're trying to exploit, but it also just helps in general trying to learn how to prevest even more machines later on, because all right, I was able to prevest this machine because I did this script that broke this specific thing. this other machine's kind of emulating a behavior like that. I wonder if I can exploit something similar to that. It helps actually knowing what you're trying to do. And be very precise. OSs are picky. Windows and Linux, when you're typing things into it, it takes things very literally. If you try to do something kind of cheeky, it's going to think, well, you're trying to run like 3 commands or something like this. Okay, I'm going to try to run them all. And you're like, no, that's not what I'm trying to do. What are you doing? You have to be careful what you're trying to type in. Sometimes it can break the machine if you're doing something wrong, like you could accidentally DOS the machine. That's kind of bad. But you just kind of have to be careful with that. And we're going into a demo, yo. All right. So, let's see. Let me plump these tabs up. All right. Is that big enough? Or need it bigger? Anybody blind in here? All right. I'm seeing thumbs up. Seeing one of these. All right. Good. Actually, where it goes. All right. So I am going to SSH into a machine real fast. Which I am going to do is JKR 10. Let me double check what the IP address of this machine is. That doesn't change. I'm doing their hack the box machine if you're curious, so I'm just trying to make sure that the machine is up. 138. All right. 10.10 138. All right. It's gonna take a little while. The SSHing is it. All right. So I skipped the initial exploitation of this machine since we're doing priv escalation. This one is I'm pretty sure it's exploitation through a web server, and you're able to get a hash of a user and such like that. So, all right. So I am on the machine. Let me bump that down a little bit. That's really freaking big. All right. So I got into the machine. I am this user JKR. I'm not the root. It shows a bunch of groups. So CD-ROM, floppy, audio. These are kind of common groups inside of a Linux machine. That's also another thing about privesking. You'll get better at it once you kind of get more familiarized of how machines are set up and how Linux kind of sets things up. So if you're confused at first how to actually do things and where things are, don't fret. Just kind of play around with the machine. Once you do more and more privesking, you'll kind of get a hang of what's normal and what's not normal. In this example specifically, that staff group is kind of weird. That's not typically a group you'd see very often on a Linux machine. If you're actually look it up, the staff group is a very specific group in Linux. It allows this user to edit the /user/local directory without group permissions. That'll come very important later on. So I'm on the machine, and I want to get to root on this machine. I need to enumerate it. So typically what I'll do is I'll go to the /temp directory, because most of the time this directory is writable by anybody, so I can write whatever I want on this machine. So I want to be able to get this enumeration script over here, is this linenum.sh. So I'm going to run a Python module called simple HTTP server, run that on port 80. So now I can go over to the actual box and do wget, I got to look at my IP first. I'm still doing it too, okay. So I do my IP address of my machine /linenum.sh, and I just download the script from my machine. As you can see right here, we got a get for this script from 138, which is the victim machine that I'm on right now. So got the script in there. Don't worry about the VMware stuff, it's a virtual machine, so that's why that's there. So I'm gonna give this thing execute permissions real fast. So now I can actually execute the script. So I'll do linenum.sh. I'll do -t. -t is the flag for linenum to do a thorough search. I just like doing that because I like to get as much information as possible. So when it runs, it's going to start spitting out a bunch of crap. And it looks intimidating, I know. It runs pretty fast, so if we were to go all the way to the front, I'll probably blow that down a little bit more since it's a lot of information. Go all the way to the top. All right, so it basically starts from the most general stuff it knows about the machine and it keeps going down to more and more specific stuff. So in the beginning, it gives you the kernel information. We know it's a Linux machine. It's on 4.9.0-8-AMD64. and we know it's a Debian 4.9.144-3.1. I told you about these version numbers. They suck. I hate them. But you have to deal with them. We get a little bit more about the kernel version again. We have a GCC version on here, so we know that as well. That might be useful if we try to exploit maybe something with GCC. We got more information about the box. The host name is right up. We got our current group, users, all the groups on the machine, the actual password file that lists us what users are on the machine, so maybe we can find out if someone else is logged into the machine, or maybe there's another user I want to actually get up as. Some of these are kind of odd, but a lot of these have these no login, so I wouldn't be able to actually get onto these users anyway. Root's the only super user, so that's the one I'm kind of going for. Tells me which files I own, and then it goes into a bunch of information which can be useful, like here, path information. So if you don't know what a path is on Linux, when you try to type a command and you don't give it a specific path, it's basically going to look for that actual executable based on the path variable. So if I type in, I want to use cat, it's going to first look in users local/bin for the cat binary. If it doesn't find it there, it's going to look here. If it doesn't find it there, it's going to look here. It's going to keep looking through all these until it can't find it. There is a very specific exploit we're going to be doing with this a little bit later, so that's actually important information. And for the rest of this, none of this is going to be really pertinent. We don't really find much that is kind of interesting for us, at least. So, actually, there is one more thing actually that is interesting. I forgot. Where's cron jobs? I gotta find it. It's somewhere in here. Right here. All right. So something's kind of specific here in cron jobs. We see that it's running this run parts command a lot. That kind of seems kind of interesting. If you don't know what run parts is, it basically runs, it'll run a binary and it will run it specifically with a given path. So it won't run on your user's path variable. It'll run on a specific one you give it. This path verb, this run parts, runs a lot of the time when a user logs in. So I might want to look at this and see what happens when someone actually logs into the machine. So this is where the pspy comes in a little bit. So we know pspy is in here. So I'm going to do another wget on my machine of 14.22 and do pspy. Is that the specific name of it? Is it 32? Yeah, 32. I want to get that binary as well. So I'm going to get that run permissions. And we got that. So I'm going to start running this. And now it's going to output almost every single command that runs on the machine. So if I were to go, where my mouse go? If we were to go over here, and I were to sh as jkr at 10.10.10.136, I think. I think it's the right IP address. Oh, it's 138. I'm dumb. And we type in the password again. We log in. Seems all right. All right. Then we go over here, and now we see, okay, a lot of things just happened. So we see the SSH from JKR, but we also see, where is it? It is right, sorry, size font is screwing with me. It's right here. Or no, it's right here. We see this run parts done here. Over here is, oh no, that does the same thing here. We see run parts and it's just run parts. It doesn't give an actual specific location of where this binary is. So we typically call this vulnerable to a path hijack. We know that our path variable is set to look at user local bin first when it's looking for binaries. And we also know that I'm part of the staff group, which I have access to right into that directory without having root's permission. So in a sense, I can make my own run parts binary, and every time someone logged in, it's going to look at my binary first and run mine. So basically, I want to make my own run parts binary and make it have a reverse shell inside of it to connect back to me. So that's exactly what we are going to do. So we cancel out of pspy. I am going to actually, I'm going to set that back up. I'm going to copy over this binary I have. So 1010 1422 slash, is it run dash parts? All right, so if you want to look at run dash parts, it's a pretty simple, just reverse shell. Goes to dev./tcp, that's my IP address, and it's going to port 4444. So if I were to copy this, or actually I gotta give it permissions to actually run first, so I'll give it 75 run parts, because I don't really care exactly what permissions it has. Then we're gonna copy this run parts over to /user/local/bin. And this is the first directory that the root is going to look at when it's trying to find this run parts binary. So if I copied in there, now I need to start up another shell. Now I want to start a listener on my machine, because this is a reverse shell, it's going to be calling back to me. So I have to be ready to catch that command when it comes back to me. So I'll do netcat, which is a network connection binary. That's usually what you do to catch reverse shells, -lvmp. So basically I'm going to listen on this. It's going to do verbose, so it's going to tell me everything that's going on, and I'm going to specify a port. So I'm going to give it 444 on this one. So if I were to, am I still logged on this machine? Oh, I am. If I were to SSH back into this machine, did I type that right? Might take a little while. Oh wait, no, I actually won't. I forgot. So it didn't actually log all the way in, because it runs my run parts binary that I wrote. It's still stuck inside a reverse shell, so it doesn't actually fully log in that user. But now on this shell that I have right here that I started the listener on, if I do ID, I'm root now, since basically that root runs that parts binary that I created from the directory that I put it in. So basically when it calls back to me, it's the root user that's calling back to me. So now I am effectively root on this machine. And that's how exactly you would prevent the machine this way, through a path hijack. So, oh, that is the wrong one. Okay. Let's see, do I have any questions? Did I lose anybody? Yeah, shout out to those people. They're G's. Thank you for signing in, web people. It's probably just Xavier, so everybody say hi, Xavier. Hi, Xavier. Thank you. All right. And these are just some good resources if you want to do any more reading on after this. Got Milk is a guy who works, if you're familiar with Offensive Security, the company, the people who do the OSCP certification. He wrote his own blog about how the beginning parts of doing a Linux privilege escalation, what to look for, some things that might be kind of useful to see. Fuzzy Security made a really good Windows PrivES guide. It shows you the very bare bone basics of things you want to look for and kind of the methodology you want to take on if you're actually looking through a machine. The third one is just another good Windows PrivES guide, same thing with the next one. ExploitDB, if you're looking for an exploit for some service or kernel, definitely go look there. That's probably going to be your best thing. There's also a command on Kali called searchbloit, which is a command line version of just searching ExploitDB for you. So if you don't actually go to the website, you can go through there and download exploits through that. Payload All Things, another good resource, and the same thing with GTFO bins. Any other questions? Everybody asleep, wants to go home. All right, guess we're done. Thank you for everybody for coming.